All right, hello chemistry. I'm going to go over the study guide as quickly as possible. By this point, you all should have at least attempted the study guide. I didn't require you guys to complete it to turn it in. Okay, but I required you to do as much as you can. That way, when you watch this video, you know exactly where you went wrong. I'm going to go over the reference sheet first. Okay, now this reference sheet, the charges, let's say like sodium, the charge of sodium is up here. Okay, all the charges are at the very top here on the reference sheet. And then where most students get confused is knowing when to use a Roman numeral. A Roman numeral is used whenever you're one of these elements. Okay, these are the elements that we don't know their charges, and you need to use the charge from the second element, right? You need to figure out the positive charge based off of what the negative charge was. And that's something we'll talk about in the future. If you don't know the Roman numerals, well, guess what? I put them here for you, right? X is 10. 9 is IX. 8 is VIII. So if you figure out the Roman numeral, or you figure out the charge of the metal, but you don't know how to write the Roman numeral, it's going to be right here. Also on the reference sheet, I showed you an example of the crisscross method. Okay, remember this is all reference sheet. You may or may not have to do all of this with a certain problem. But this right here is an example of the crisscross method, right? Let's say I have lead with a positive 4 charge and then oxygen with a negative 2 charge. Let me make this a little bit smaller. Okay, the crisscross method, you take this number and you put it here, and then you take this number and you put it here, right? You cross them. What that gives you is you don't bring where most students make their mistake is they try to make this a negative 2, right? Because this was a negative 2. You don't bring down the charge, you just bring down the number. Okay, and you end up with Pb2O4. Don't forget you can always reduce if possible, right? So 2 and 4 here, they can both be divided. 2 over 4 is the same thing as 1 over 2, right? Because you divide both the top and bottom by 2. So this is Pb1O2. Also on the reference sheet, I have all of the polyatomic ions. This isn't a complete list, but this is a complete list of all the ones that will be on the test. Okay, so this is a reference for everything that I'm going to give you. If you want to know what HPO4 is, well, it's right here, HPO4, hydrogen phosphate. If you want to know what HCO3 is, well, you have to find it. It's right here. This is hydrogen carbonate, right, or bicarbonate. If you want to know the charge of sulfate, well, sulfate is right here. This is the polyatomic ion, SO4, and the charge of sulfate is -2. It's what's up here in the top right corner. That's going to be the charge, right? Another thing where students like hypochlorite is right here, ClO minus. Well, what's the charge of hypochlorite? It's just a negative sign. Well, if it's not written, it's a 1. That's a -1 charge. And then the last two things on the reference sheet is when we're naming compounds, and the last thing is an element, right? Well, it's going to end with IDE, right? So if it's sulfur, it's going to be sulfide. If it's chlorine, you have to change the name to chloride, right? We call this the IDE name of the compound. And then the last thing you need to know is the prefixes. And this goes for covalent compounds either. Remember, covalent compounds is two non-metals. Okay? If you have 2 non-metals, this is called a covalent compound. Let's say I have something like N2, N2O2, right? Well, 2 is di, right? So you would call this dinitrogen dioxide. Let's say I had let's just go easy, right? Let's say I had P3, right? Well, you would call this tri 3 for triphosphorus, because P stands for phosphorus. Or if this was the last element, you would call this triphosphide. Right? That's how you use the prefixes. The prefix is there to tell you how many there are. So let's go ahead and put into practice everything that's on this worksheet. So number 1, what is the charge of lithium? So I'm going on the worksheet, I go here, lithium right here. The charge is at the top, -1 or +1, right? You pretty much, what you do to do this is you find the element and you go directly up. Okay, the charge is +1. And these are numbers you have to memorize how to write on your tables. I won't give you these in the future. +1, +2, +3, -1, -2, -3. Chlorine, -1 charge. Phosphorus, a -3 charge. Selenium, a -2 charge. Okay, the only ones we don't know the charges of is these guys right here. Right, everything inside of this box right here. These, we don't know any of the charges for these guys. Okay, the way you find these charges, the way you find the charge of these guys is based off of the non-metal. We will talk about that in the future. The exceptions would be stuff like there's 3 transition metals where we actually always know their charge. Zinc always has a +2 charge. Silver always has a +1 charge. Cadmium also has a +2 charge. You actually don't need to memorize this. I made sure not to cross this out on the periodic table of elements, right? So you know the charges of those guys. It's written right there for you. That's it for this. I can do a random one like cesium here. Let's try to find cesium. Cesium on the periodic table is right here. I know that's group 1, so I already know the charge, but let's scroll up and find out, actually. So cesium's right here. If you draw an arrow straight up, right, that charge is a +1 charge. So you go here on the worksheet and you write +1 charge. I don't want to spend too much time on that because that's not what you guys are here for. You guys are probably here because you're stuck on the other ones. What is the chemical symbol? This is going to be on the test too. Well, you find it's right here on the table. Carbon is right here. The chemical symbol is C. Right? So here, oops. Here for an answer for carbon, you double click and just put C. Okay? What's the chemical symbol? Let's pick a random one. Nickel. Well, nickel is right here. Okay, the hard part for you guys is going to be finding it on the periodic table. The chemical symbol for nickel is Ni. So you would double click and write capital N, lowercase I. Make sure you use the correct capitals and lowercase letters. So francium, let's do francium. I'll do francium and fluorine, right? Francium right here, fluorine is up here, right? Francium is Fr, fluorine is just a capital F. So we go here, francium Fr, fluorine capital F, right? That's how you solve these problems. Now moving on to a little bit harder ones, right? Now we want to know if we can identify ionic compounds versus covalent compounds. Okay, if we remember from class, there's a stair-step line, right? It starts to the left of boron, and you just draw stairs going down. Anything to the left is a metal, anything to the right is a non-metal. The only exception is hydrogen, which is also a non-metal. If you have a metal and a non-metal that are bonded together, that's called an ionic compound. It doesn't matter which one. Let's say this metal and this non-metal, that's ionic. If I have a non-metal and another non-metal, that's a covalent compound, right? Metal or non-metal, fluorine, non-metal, sulfur, that's a covalent compound. So let's identify some of these, right? Magnesium and chlorine. Well, magnesium is here and chlorine is here. That's a metal and a non-metal. We would call that ionic. Phosphorus and oxygen. I would find those here. Phosphorus and oxygen. That's 2 non-metals. We would call that covalent. Covalent. Lithium and oxygen. Lithium is here. Oxygen is here. Right? This is a metal and a non-metal. We call this ionic. Calcium and nitrogen. Calcium and nitrogen. This is a metal and a non-metal. We call this ionic. Copper and oxygen. Or sorry, carbon and oxygen. Capital C, capital O. Right? That's not copper. Copper is Cu. There's no U there. There's another mistake students make is CO, cobalt. Right? This is capital C, lowercase o. This is an element. It's not even a compound. Make sure you're paying attention to the capitals. This is carbon and oxygen. This is a covalent compound. And then some things that are just like dead giveaways to ionic compounds. If you see a Roman numeral, right, that's for sure a metal, and an oxygen's a non-metal. So this, you don't even have to look it up, right? This is covalent. Sorry, ionic. This is ionic because it's a metal and a non-metal. Potassium and chromate. Well, this is not even an element. Anytime you see a polyatomic ion here, this is a dead giveaway, ionic compound. Okay. Sodium sulfate, again, another polyatomic ion, so we call this ionic. Cn. Well, let's look. right? Carbon and nitrogen. This is a covalent compound. Lead. I see a metal and a non-metal. This is covalent. Right? Remember this Roman numeral is always the charge of a metal. It'll always tell you the charge of a metal. So dead giveaway, this is a metal. I memorized that that's a non-metal. I think we've had phosphorus. Oh, we didn't. So phosphorus is right here. Right? That's a non-metal. Remember, phosphide is the IDE name of phosphorus. CO2, well, that's carbon and oxygen again. We already figured out that was covalent. NaBr, let me find those, right? Sodium, Na, and bromine, Br. That's a metal and a non-metal. So that is ionic. And chlorine is right above bromine, so it's also a non-metal, so this is also ionic. Okay, that's how you would do those. Now moving on, it's getting a little bit tougher now. Write the names of the following compounds. So I'm going to do every single one of these. I'm not going to skip around anymore. You might get stuck on one of these, so I don't know which one it is. So I'm just going to go ahead and solve all of them. Write the names of the following compounds. So C4H8. I know C is carbon, H is hydrogen. So carbon and hydrogen. Hydrogen, right? Now remember, the second element will always get its IDE name. So if we look on our reference sheet, the IDE name is right here, hydride. There's so few of these, you will eventually get these memorized. That's it, carbon hydride. Now I know this is carbon. This tells me I have a carbon and I have a hydrogen, but it doesn't tell me how many, right? I need to put words here in front called prefixes to tell me how many there are. So in front of carbon, I'm going to say there's going to be 4 carbons, but I can't just write 4. I have to use the prefix, which tells me the prefix for 4 is tetra. So this is called tetracarbon. Tetracarbon. What? Well, right. Well, what about hydrogen? How many hydrogens? There's 8 hydrogens. How do I know there's 8? Well, that's what this number tells me, right? This little subscript tells me how many of that element there are. So we find right here, octa. 8 is octa. So I will call this octahydride. N2O5. Okay, well, I know this is nitrogen and oxygen. I know this is nitrogen and oxygen. There's 2 nitrogens. We call that di. There are 5 oxygens. We call that penta. I'm not going to go back and forth between the reference sheet because I do want to do this quickly so the video is as short as possible. So the 2 I have here, O and F. O is oxygen, and F is fluorine, right? But remember, the second element should always get its IDE name, so it's called fluoride, right? And you want to tell me how many? Well, this is monooxygen. This is monooxygen, but the first element, you don't want to ever say mono, so you just leave it. So, right, you delete the mono. And this is difluoride. Why did this pop up? Did I click on that? Okay, sodium bromide, right? Na is sodium, Br is bromine. Sodium bromide. Now I know, I don't know these are all covalent, right? This one's ionic. So the thing is, I just ran into an ionic compound, okay? Ionic compounds are a little bit different. Okay, we didn't identify whether these are covalent or ionic, so I just lucked out. C and H, this is covalent. N and O, those are covalent. And O and F, those are also both nonmetals, it's covalent. But as soon as you get to ionic compounds, things change. And this is why it's important for you to identify metal or whether or not a compound's ionic or covalent. Because if it's covalent, there is a possibility that you need Roman numerals. Okay. On top of that, with ionic compounds, you will not need prefixes. You never write anything here. So I already know I'm almost done. As long as this doesn't need Roman numerals. So let's check. Right. Sodium on the periodic table. Sodium is right here. Okay. Right here. Sodium does not require a Roman numeral because it's not inside of this little box here. right? So it does not require a Roman numeral. So we're just going to go ahead and just write sodium bromide. We're done. That's the correct answer. So here's magnesium and chlorine. Now, a little trick. The first element is going to be the metal. That's the only one that's going to need the Roman numeral. So I'll just take magnesium here. I'll look for it. Magnesium is right there. It is not inside the box, so it does not require a Roman numeral. So I'm going to go ahead and just write magnesium and chlorine. Magnesium chloride, right? Because the second one should always get the IDE name. Okay, this next one, Ba and N. Well, if I look for Ba, it is right here. It does not require a Roman numeral again. So I'm going to call this barium. And then N, right? Do I call it nitrate, nitrite, nitride? Well, nitrate and nitrite, don't forget, those are the names of polyatomic ions, right? This is nitrate, nitrite. This is nitrate. I don't want to call it that because there's no oxygen on this compound. So make sure you call it by its correct IDE name, nitride. And make sure it's all lowercase. All right, LiP. This is a metal and a non-metal. It's ionic. Lithium is right here. It does not need a Roman numeral. I'm just going to keep doing this until we find one that needs a Roman numeral. Right, so this one is going to be called lithium phosphide. Okay, CuO. Cu is actually right here. This one does require a Roman numeral, so this one might require a little bit more work. Let's figure it out. We do know, though, that Cu is copper. Copper. Okay, and we know it will need Roman numerals, so I'll add parentheses. And then O is for oxygen, which is oxide. Okay, we got the names. Now all we need to do is figure out what goes inside of parentheses there. So there is a way, there's the method I've been teaching you to figure this out, right? You can draw a little table. On the left side of the table, you write how many coppers you have. In this case, we have 1 copper. On the right side, you write how many oxygens you have. In this case, we have 1 oxygen, right? There's no little subscript here, so it's always going to be a 1 if there's no subscript. So there's 1 oxygen. And then you look on the periodic table for the charge. The reason why we need Roman numerals is because we don't know the charge of copper. But what we do know the charge of is oxygen. So if you look on the periodic table, you'll find that oxygen is right here, and it has a -2 charge. So I go back here, I redraw my table. Let's see if I can do this. Yeah, I get my table back, and then I know oxygen has a -2 charge. So overall, since there's only 1 oxygen, right, then overall it's a -2 charge. Well, what can I do over here on the left side to balance that -2 charge? I can have a +2 charge, right? That balances because +2 plus -2 equals 0. In order to get a +2 charge on the left side, since I only have 1 copper, well, that 1 copper needs a +2 charge. How do I indicate it has a +2 charge? I write 2 here in the Roman numerals. Okay, that's what that Roman numeral is. It's to tell you the charge of one of the metals. So it'd be copper 2 oxide. Now let's go here, Fen. Fe is right here. It also requires a Roman numeral. So let's write what we know so far. Okay, we know iron, Roman numerals, nitride. Because the N is nitrogen. Remember, the second one will always get its IDE name. But we need to know what goes inside these Roman numerals here. So I'm going to show you the same method. I'm not going to show you the shortcut crisscross method or uncrisscross method. You can go ahead and figure that out on your own if you want. That won't work every time, so I'm not going to show it to you. You're going to write your table, and you're going to write how many irons you have on the left side. Well, that 3 tells me I have 3 irons, so I'll write Fe, Fe, and Fe. So I have 3 irons, I have 2 nitrogens. I have N and N. So this Roman numeral, I don't know the charge of iron, so I can't do anything with that yet. But I do know the charge of nitrogen. The way I know that is if I go here to the periodic table and I find nitrogen, okay, and I look directly up, the charge is -3. Okay, so I'm going to give each nitrogen a -3 charge. -3. Overall, what that's going to do, it's going to give me a charge of -6. And what I need to do from there is I need to figure out what charge will balance that. Well, the overall charge that would balance that is a +6. Well, now how can I get a +6 with 3 irons? Well, if I have a +2, right, if each iron, they have to be the same, by the way. I can't give 1 a 2 and 1 a 3, right? They all have to be +2. If I have all +2s, 2, 4, 6, that would give me a +6 charge. So each iron must be iron 2. And that's what you would write here in parentheses, iron 2. Let's go ahead and try this one. Right, again, I have copper and oxygen. I already know, based on problem number letter H, that copper needs a Roman numeral. Okay, so I'll draw my little table. I will also write what I know already, right? I know it's copper. I know it's copper oxide. Just like before, it's copper oxide. But the copper is probably going to be different since there's 2 of them. Okay, so I'll put a little bracket here. Fix that. Okay, what do I know? I know I have 1 oxygen based on the fact that there's no subscript. And based on the fact that there's 2 subscripts, I know I have 2 coppers, right? 1, 2. Don't forget, Roman numeral means we don't know the charge, so we can't look for this guy. We're figuring this out. What we do know the charge of is the negative, is the non-metal. So let's look for oxygen. Oxygen is right here. Okay, directly above it, it has a -2. So we know oxygen has a -2 charge. So I'm going to go ahead and give this 1 oxygen a -2 charge. Since there's no other oxygens, overall the right side has a -2 charge. Now what's going to balance that -2 charge? Well, I have to have a +2 charge, right? Because +2 minus 2 equals 0. In order to have a +2 charge, each copper needs a +1 charge. And that's what would go here inside the parentheses, right? Copper 1 oxide. All right, again, I have copper. Why did I put copper on here so much? Who even knows? So again, I have copper. We know copper needs a Roman numeral, right? Based on the fact that we've done this 3 times already. So it's going to be copper something oxide. Right? We don't know the charge of copper, but again, we know the charge of oxygen. Oh no, sorry, this is an oxide. Wow. Sorry, this is SO4, right? I just completely missed out there's a sulfur there. Let's go to our reference sheet and look for SO4. Right? Do you see an element that's called SO4? I for sure don't. Okay, so now what you're going to have to do is you have to think about something called polyatomic ions. Okay, the polyatomic ions are like this one, SO4, sulfate. Another thing to keep in mind is that these will also tell you the charge of the sulfate. So let's just go ahead and write that down because it's important to have as much information as possible. SO4 with the -2 charge. So I'm going to write SO4 with a -2 charge. And then copper, right, we don't know its charge, but we can draw our table. And let me make this a different color. And we know, right, that copper, we're going to have to figure out that element, but we know that sulfate has a -2 charge. We know there's 1 sulfate. Okay, SO4, how many of those are? There's only 1 of those, right? The whole thing, there's only 1 of those. Even though there's 4 here, that 4 tells you have 4 oxygens. Not that you have 4 sulfates. You have 4 oxygens in 1 sulfate. How many coppers do I have? Well, I have just 1, right? Because there's nothing written there. So I have just 1 copper. So if the 1 sulfate has a -2 charge, then the 1 copper must have a +2 charge to balance that out. So this would be called copper 2 sulfate. All right, let's move on. NaPO4. Well, I've never seen this element on the periodic table. Okay. It's likely a polyatomic ion. What you can do if you're not sure is just look for it. Okay. Do I see PO4 anywhere here? I do. I see it right here. PO4 with a -3 charge. It's called phosphate. I can even double click and just write phosphate right now. Phosphate. Because we know that the second word is going to be phosphate. But what's the first word going to be? Well, let me look. So the periodic table, the first one is Na. I see Na right here. It also does not require a Roman numeral. It's not inside of this box, so it doesn't need a Roman numeral. So I could just get away with calling this sodium phosphate. And that's it. That's the answer. Okay, now I'm on the last one. I know this video is 25 minutes long so far, so let's try and get through it really quick. So write the chemical formulas of the following compounds. Iron 3 nitride. Well, this is cool because the Roman numeral tells me the charge of the iron. I don't even need to look for that. I know it's Fe with a positive 3 charge. My F looks terrible though, but you know, that's an F. Nitride. I see IDE. This isn't nitrate. This isn't nitrite. This is nitride. So I know this is nitrogen. Let me go find nitrogen on here. Here is nitrogen. And if you draw a line straight up, it has a negative 3 charge. So I'm going to go ahead and write that, negative 3. Well, you can always do the crisscross method. I think I'm just going to do the crisscross method eternally now. Right? You put the 3 here, you put the 3 here. So you end up with Fe3N3. Okay, but you're not done because this can get reduced, right? Divide both of the elements by 3, you'd end up with just Fen. Fen. Now let's try this one. Iron 3 nitrate. Okay, it seems the same, but it's actually different. Let's see why. Fe has a positive 3 charge. Nitrate, I know this is not an element, and if I don't know, I can always just double check to see. Let's look at the polyatomic ions. Do I see nitrate anywhere? I do. Nitrate is right here. NO3 with a -1 charge. Let me go ahead and write that right away. NO3 with a -1 charge. Remember, the ones we don't write, I'm doing it for explanation. That way it's easier to understand where these charges are coming from. Now, the thing is, let's draw our table because we have a problem now. Overall, on the right side, I see a -1 charge. Overall, on the left side, I see a positive 3 charge. I need this to balance out. If I add another iron here, now it's positive 6. Now it's worse, right? It's less balanced. So I'm going to add more nitrates. Nitrates, right? NO3 with a -1 charge, another NO3 with a -1 charge. And overall, that's going to now give me, right, -1, -1, -1. That's going to give me a -3 charge. Now this will balance. So let's go ahead and write that. I have Fe, there's only one of those, but we never write our ones. NO3. Okay, cool. But I don't only have one NO3, right? Remember, NO3 is nitrate. That's one nitrate. I have 3 NO3s. So I have to add parentheses and put a number out there to show I have more of that polyatomic ion. In order to make the numbers subscripts, you highlight it, press Control comma. Okay, highlight, Control comma. And that'll be your final answer there. Let's move on. So copper 2 hydrogen phosphate. So we know copper 2. Luckily, we don't have to look it up. We already know it's a positive 2 charge because that's what this Roman numeral tells us. Positive 2 charge. Hydrogen phosphate. Oof, I don't know what that is. Let's look it up. Hydrogen phosphate. Hydrogen phosphate. Found it. HPO4 with a -2 charge. So HPO4, the -2 charge. Now you can crisscross and reduce, but if you want to think about it logically, right? How many coppers do I need to cancel out the -2 charge of the hydrogen phosphate? Well, it's only 1. I need 1 for each to cancel that. So this would be CuHPO4. Right? CuHPO4. Remember, highlight, press Control comma in order to make this a subscript, and that's it. I have 1 copper and I have 1 hydrogen phosphate, and that's it. I'm done. This one, I can tell is covalent. You can tell just by the name real quick because I see prefixes. Remember, prefixes have to do with covalent bonds. Dinitrogen. Okay, some students are going to make this mistake. They're going to do 2N and then 3O, right, for 2 nitrogens and 3 oxygens. But when you're going the other way, right, when you're going from the formula to from the name to the formula, you have to write the number of nitrogens after the symbol. So it's N2O3. There are 2 nitrogens and 3 oxygens, right? You can highlight, control comma to make these subscripts and move on. Ooh, another covalent compound, right? Super easy to recognize because I see prefixes. This is called tricarbon, so I write C3 for 3 carbons. C3. This is called tetrafluoride, so I write 4F because there's 4 fluorines. If you don't know the chemical symbol for fluorine, that's fine. Go up here to the periodic table. It'll take you a minute, but you'd find fluorine, and then you'll see, oh, the chemical symbol is just an F. Hopefully not like my letter grade. Right? I would highlight, control comma, highlight, control comma. And that's it, right? Tricarbon tetrafluoride. Carbon dioxide. Ooh, I see another prefix. Cool, it's covalent. Carbon, capital C, oxygen, capital C, oxygen, capital O. There are 2 oxygens, but I don't know how many. I don't know how many carbons there are. What the heck? Well, the way you know that is because there's a rule, right? If mono is written first, monocarbon, you actually don't write it, right? Just like the rest of math and the rest of chemistry, typically you ignore the ones, they're useless, so ignore them, right? 1 times anything is itself. That's why it's useless, so don't even worry about it. So this would be carbon 1. But again, we don't write the ones. The ones are useless. We ignore them. Control highlight, control comma, good. The next one, sodium chloride. Well, I know this is likely ionic, right? Because I don't see any prefixes, but I don't know for sure, right? So in order to know for sure, what do? I can go to the periodic table. I see sodium here, and I see chlorine right here. This is a metal and a non-metal. Good. Now I know for sure I do not need prefixes. I do not need to worry about the prefixes. I just say NaCl, okay? But the problem is, again, what you need to do is you need to worry about the charges. So let's make sure the charges cancel. Okay? Let me do that later. Na is here. It has a positive 1 charge. Chlorine is here. It has a negative 1 charge. All right, let me show you. Yeah, positive 1 charge, right? Sodium has a positive 1. Chlorine has a negative 1. So I'm going to go here. I'll write my little table. Right, Na with a positive 1 charge. Cl with a negative 1 charge. Overall, this would cancel, right? I don't need to do anything else. There's only 1 of each. Calcium carbonate. Well, let's do this together. Well, no, I see right here what I talked about earlier, right? Carbonate. It's a polyatomic ion. That's a dead giveaway that this is an ionic compound. The way I know it's polyatomic is this does not end in IDE. So that's an indication that you have a ionic compound. Let's look it up. So carbonates, let's make sure that we do have a polyatomic ion. And yeah, sure we do. Carbonate, CO3 with a -2 charge. So that's what I'm going to write. I'm going to write CO3, -2 charge. And then I'm going to write Ca. But I don't know the charge of calcium. So I'm going to go ahead and find on the periodic table. Okay, calcium is right here. And it has a +2 charge. So I want to go ahead and write Ca +2 and CO3 with a -1 charge. So CaCO3. Highlight, control comma. I have 1 carbon and 1 calcium, right? Because the +2 cancels with the -2. That's all we need. Let's do the next one. Potassium bromide. So let's look for it on here. I see potassium here. Oof, all of these ones are easy, right? You don't have to worry about the crisscross method. Potassium's right here, bromine's right here. +1 charge, -1 charge. So I'm going to go ahead and write potassium bromide. And that's it. That's the end of the review sheet. Oh, nope. Sorry. Potassium has a chemical symbol of K. Bromine has a chemical symbol of Br. We only need 1 of each for that to be a neutral charge. And we're done. That's it, right? All right. That's the whole study guide. If you guys can do all of those problems, I guarantee you're going to get 100% on the test. That's all the questions I could possibly ask you. All right. Bye. Good luck.